Hello, guys. So this is section 1.5 lecture about solving inequalities. So there are four objectives. The first one will be use interval notation. So I'm going to start with the first objective, interval notation. So interval notations, I have to give you the definition, but an open interval uh, denote by a comma b. What that means, this interval consists of all real numbers x, for which we can say such that x is between a and b. That means x is greater than a and x is less than b. So that's open interval. This is the condition. Next one, it's going to be a closed interval. Denote by, in brackets, we put in AB, consists of all real numbers x such that x is between a and b, and we also including a and b. Okay, so similar like the open interval, but in this case we have closed intervals, so we including a and b right here. In previous one we not including a and b. Okay, next one is going to be the definition of the half open or half closed intervals, or that's the one which looks like this: parenthesis a comma b bracket. So in this case, consisting of all real numbers x such that x is greater. Again, I just want to make sure that this is parentheses. You guys see it's parenthesis. Such that x is greater than a, however, is less or equal b. So this is half open, or we can say, so this is half open interval right here, and then half closed interval. Okay, that's going to be half open, half closed, and we can have something like this: bracket, which is we including a, parenthesis b, which means that means that x is greater or equal a, however is less than b. Okay. And I will be back. Okay. Let's go back. So next what I'm going to give you the interval notation, and I'm going to show you how you're going to graph it. So next, let's talk about interval notation. So I'm going to give you examples when I'm going to create the table that we're going to have interval, and then I'm going to give you the inequality with match with that interval. And then I'm going to show you how to graph each. So you guys have something to follow. So the first interval, it's going to be interval from A to B. So this one, if we're talking about using inequality, that means again that x is greater than A, less than B. And how we're going to graph it, on the number line you're putting A and B, you keep open circle, and you're shading everything between A and B. Okay, next one, we're going to have close interval, A comma B in brackets. If we're talking about inequality, that means x is greater equal A, less than equal B. Open. Give me a second. Here, have the ice cream. And to graph it, so we're putting A, B on the number line. In this case, since you have brackets, so we're including A and B, it's part of the solution, and all the numbers between A and B. So the first number of that solution will be A, the last one will be B. In open intervals, you cannot really tell us what is the last number. We are approaching B, but B is not part of the solution. Okay? Then we have half open interval, which is bracket A comma B. So if we're talking about inequality, that means x is greater or equal A. However, it's less than B. Okay, let me just extend the graph a little bit. So to graph that, we're going to put A, B. The first solution will be A. The last solution is going to be number super close to B, but we're not including B. Okay. Next one, we have half open interval. So that will be parentheses A comma B. That means x is greater than A, but less than equal B. So the difference is right now that we cannot really tell what is the first number of that solution because we're not including A. So any number right after A, but the last solution will be B. So you may think about B being maximum. So here we have maximum before we had minimum. Okay, so we have interval like this, bracket 8 infinity. That means that x is greater or equal to A. And to graph it, that interval, you're going to put A on the number line. We including A as a solution, and we're shading all the numbers which are greater than A, which is everything to the right. Okay. Next one will be interval from A in parentheses to infinity. So this is just x greater than A. And to graph it, you're putting A on the number line. You're going to keep open circle because we're not including A, and we're shading everything to the right. Like you see, inequality match with the direction of number line which we need to shade it. So I hope this is the review for most of you. Then we have interval from negative infinity to a bracket. That means x is less than equal a. To graph this inequality, to graph this interval, you're putting a on the number line. In this case, a is a part of the solution, and also all the numbers smaller than a, so I'm shading everything to the left. And then we have from negative infinity to a parenthesis. That means x is less than a, and the graph looks that way. You're putting a on the number line. In this case, a it's not part of the solution. However, all the numbers less than a, they are part of the solution. So we're shading everything to the left. And the last one, which you see, it's from interval from negative infinity to positive infinity. That means technically that all real numbers are the solution. So to graph all real numbers, you will shade entire number line. Okay. So we review the interval notation, which match with inequality notation and graph. And now we're going to do the examples. So example, I want you to write each inequality using interval notation. And the first one is 1 less than equal x less than equal 3. So you need to write each inequality using interval notation. So this is that case right here where x was greater equal a less than equal b. So we have brackets a comma b. So we're going to use the brackets. We're putting 1 comma, we're putting 3, and we're closing. B, we need to write this inequality using interval notation. So we have x greater than negative 4, however less than 0. So that's the first inequality, which is in green. So we're going to put in the parenthesis a comma b. In our case, a it's negative 4. So the solution will be negative 4 comma 0. So the solutions are all real numbers from negative 4 to 0, or you can read between negative 4 and 0. And next one, it's x greater than 5. So x greater than 5. So that's the one right here, x greater than a. So we're going to have 5 comma infinity. So the solution will be 5 comma infinity. And the last one, D, is x less than equal 1. So x less than equal 1. So here we're talking about this inequality which match with this interval, which is from negative infinity to a. In our case, will be from negative infinity to 1 bracket. So we have from negative infinity to 1 bracket, because we're including 1. When you have inequality and equal sign, that means you're always going to have a bracket. So that was practice. Okay, now we're going to do the opposite in next example. So this is going back to basic, but it's very important. Like chapter 1, it's the review for most students, but I do understand that some students didn't see algebra for a long time. So it should be like a review. You guys should see that before, okay? So write each interval. Here we have to write each interval as an inequality involving x. So I'm going to give you opposite. I'm going to give you interval notation, bracket 1 comma 4. So when you see two numbers, that means that you're always going to have a combined inequality. And in this case, x is greater or equal 1 because we have that bracket, but it's less than 4. We have less than because of the parenthesis. For b, you have parenthesis 2 to comma infinity. So parenthesis 2 to infinity. So this is that example. And you need to write using this inequality. So that will be x greater than 2. So the solution will be x greater than 2. C, we have bracket 2 comma 3. So again, when you have two numbers in interval, that means you're going to have combined inequality. That will be x greater equal 2 less than equal 3 because of the bracket. So you have inequality and equal sign. And this is the example. And this is this one, bracket AB. So that's the inequality which you're going to use. And D, we have from negative infinity to negative 3 bracket. So negative infinity to negative 3 bracket. So this is this one. So we're going to say that x is less than equal a. In our case, a it's negative 3. So we're going to have x less than equal negative 3. So that's the one. So we have x less than equal negative 3. Okay. So we practice this one, and now we're going to talk about properties of inequality. So this is objective 2. The second objective is use properties of inequalities. So there's a couple properties. So the first one is non-negative property. That means that any number, square it, it's always greater than 0 or equal to 0. That's non-negative property. So non-negative property, which definitely makes sense. The next one is, I'm trying to make quickly shortcut, addition and subtraction. I will put them together. The next one will be addition and subtraction. Property. I would just write this down because it just make more sense if I would write this down. We can add or subtract any numbers from both sides of inequality and the inequality symbol stays the same. So I don't want to give you the formula because it's confusing, it doesn't make sense. So for example, something like this. You have x plus 5 is greater than 7, and we need to solve an inequality like that. So what I'm going to do, I want to isolate x. So I want to subtract 2 from both sides, like solving equations. So I'm subtracting 2 from both sides, and I will end up x greater than 5. So when you add or subtract numbers to both sides of the inequality symbol always stays the same. Okay, so that's addition subtraction property. Next one is multiplication property. Okay, so multiplication property tells you that if you multiply both sides of inequality by a positive number, then the inequality symbol stays the same. So example for this one will be 2x is greater than 4, and you want to solve for x, so I'm going to multiply both sides by 1/2, or you can say divide by 2, because multiplication is the same thing as division. Division is multiply by a reciprocal. So this is multiplication slash division property. Okay, so I multiply both sides by 1/2. Since I multiply by positive number, so that will cancel, the inequality symbol stays the same. Okay, however, if you multiply by negative number, so if you multiply or divide by the negative number, the inequality symbol switch to the opposite. Reverse. You know what? Let me just put reverse then, and because that will be that will sound better. Inequality symbol reverse. Okay. So let me give you an example. We have negative 2x less or equal 4. So to solve for x, I will divide both sides by negative 2. So I'm dividing both sides by negative 2, and that will give me x, and I reverse inequality symbol, and we only do that when we multiply or divide by negative. So less than or equal will become greater or equal, and here we have just negative 2. Okay, so that's the multiplication slash division property. And reciprocal property, it's the last one, and we're going to focus on solving inequalities. So the next one, reciprocal. So reciprocal property tells you that if a is greater than 0, which is positive number, then Reciprocal of a, which is 1 over a, it's also positive. Okay? Um, because think about it, just example. We know that 2 is greater than 0. So we know that reciprocal of 2, which is 1/2, it's also greater than 0. Or again, you can do the opposite of that. So if you know that fraction is greater than 0, then reciprocal of that fraction, which is a over 1, it's also greater than 0. So that's one. And another one will be if a is less than 0, then the reciprocal also will be less than 0. Or you may see if reciprocal is less than 0, then the a over 1, it's not greater, it's less than 0. So I will give you an example here. We know that -2 is less than 0, then reciprocal, which is -1/2, of course, has to be also less than 0. Or example for this one, negative, let's put that way, 1 divided by -4, it's less than 0, then the reciprocal of that, which will be -4 over 1, of course, is less than 0. So I think we'll use it a couple times. So we're going to start solving inequalities. So to solve inequalities, let me just write a note. To solve inequalities, use the same rules for solving equations which means you want to isolate variable on the left side and remember to reverse the inequality only if you multiply or divide by the negative number. Okay, so we're going to do a couple examples of solving linear inequalities. So example, solve the inequality, solving linear inequalities. The first one will be 4x plus 7 is greater or equal to x minus 3. So solve linear inequality and graph the solution set. Okay, so here what you want to do, first you want to bring x's together to the left side, so that 2x has to be moved to the left side. So the same way like we're solving equations, since I'm moving numbers or expression to the other side using the opposite, so you need to subtract 2x from both sides of inequality. So that will cancel, and we have 4x minus 2x, which is 2x, plus 7. And remember, when you're adding or subtracting, the inequality stays the same, greater or equal -3. Next, what you want to do, you want to isolate x, which means that positive 7 has to be moved to the other side. Since you see positive 7, you will subtract 7 from both sides. So that will give you 2x greater or equal -10. And the last step, you always want to isolate x since you have 2 times x, so you will divide both sides by 2. Since you divide by positive, inequality symbols stay exactly the same, so we have x greater or equal -5. So this is our solution. To graph it, this is how you will graph. You will put -5 on the number line. You're going to include -5 in your solution because of the equal sign, and greater, that means we're shading everything to the right. So this is the graph. And if on my MATLAB they will ask you to write the solution using interval notation, so interval notation is bracket -5 to infinity. Okay. Next, what I want to do, I want to solve combined inequalities. So that's objective 3. Solve combined inequalities. Um, so example. Combined inequalities, it's the one when you're putting two inequalities together. So we have -5 less than 3x minus 2 less than 1. So we need to solve it and graph it, the solution set. So what you can do with the combined inequality, rewrite as two inequalities. So the first inequality, it's this one, -5, it's less than 3x minus 2. So we have -5 is less than 3x minus 2. Again, I prefer to have variables on the left side. So I'm just going to rewrite it as 3x minus 2, it's greater than -5. And when you have combined inequalities, you have word and the second inequality is this one, 3x minus 2, it's less than 1. And 3x, it's less than 1. And now we're just going to solve both inequalities for x. So I'm going to add 2 to both sides, and that will give you 3x, it's greater than -3. Divide each by 3, and we're getting that x is greater than -1. Here, to solve the second one, we're also adding 2 to both sides, and we have 3x less than 3, and just divide each by 3. That will give you x less than 1. So word end means intersection. So when you solve two inequalities, what you're going to do, graph. So first, we rewrite as two inequalities. Second, graph both solutions on the same number line. on the same number line, graph both solutions on the same number line, and find the intersection. So I'm creating number line. I'm going to graph both. In green, it's going to be the first one, x greater than -1. So I have -1, open circle, and I'm shading everything to the right. In orange, it's going to be the second one when we have x less than 1. So 1, open circle, and we're shading everything to the left. So the solution, word end means intersection. So the solution of this combined inequalities is intersection of both inequalities. That's where you see two colors overlapping. Okay, so this is the solution. This is the intersection. So the solution is parenthesis -1 comma 1. So that's the interval from -1 to 1. So that's how you solve combined inequalities. Just rewrite as two inequalities, solve each inequality, graph them together, and look for intersection of the graphs, and that's going to be the solution. Okay, the interval from -1 to 1. Next, what I want to do, I want to talk about how to use the reciprocal property. So that will be the objective number 4. So this is the objective number 4. Reciprocal, using the reciprocal property. To solve inequality. Okay, so that's our objective. And let me show you how you can use the reciprocal property. So let me give you an example. Solve the inequality 4x minus 1 bring to the power of -1 is greater than 0. So just remember that expression, bring it to the power of -1, means take the reciprocal of your expression, that is the same as 1 over x to the power of 1. So what I'm going to do, first, rewrite 4x minus 1 to the power of -1 as 1 over 4x minus 1 to the power of 1, which is the same as 1 over 4x minus 1. So here, this inequality, it's going to be 1 over 4x minus 1 is greater than 0. Okay? And what I'm going to do, I'm going to use the reciprocal property So if the reciprocal of A is greater than 0, that means that A has to be greater than 0. So in this example, you may think about 4x minus 1 is your A. Okay, so you may think about that this is your A. So you can rewrite that as, since reciprocal is positive, that means 4x minus 1 is greater than 0, and just solve this inequality. For x. So I will add 1 to both sides. So we have 4x is greater than 1, and just divide each by 4, and that will give you x is greater than 1 over 4. So this is the solution. If you want to graph it, You're putting 1, 4 on the number line. We're not including 1, 4, so open circle, and we're shading everything to the right. And interval notation is from from 1, 4 to positive infinity. Okay, so that's it from section 1.5. For the next video, which is section 1.6, I will probably review a couple problems, maybe do a little more inequalities, just to make sure that you guys feel comfortable. But that's all 4 major objectives for section 1.5. So thank you for watching the video.